of the points where the curve meets the coordinate axes. Now at the moment, obviously we've got the full equation here that needs factorising first. So we have x cubed minus 6x squared plus 9x. Now these are the nicer versions of the cubics, because these are nice and easy to get a nice little quadratic out of them in order to factorise quite nice and simply. If we went much more complicated on these, we'd have to use the factor theorem, and obviously that sort of starts incorporating quite a lot of math, so we get quite a large question if we were to do that. But obviously check out the factor theorem if you want to have a look at factorising some of the harder cubics here. But we're going to just focus on some of these slightly easier cubics for drawing these, as it can get quite complicated otherwise. But let's have a look. Now in order to factorise this, we can take out a factor of x to start with, and when we take x out, as there's no number at the end, we get inside a nice quadratic here. We get x squared minus 6x plus 9. Okay, so that obviously gives us our first solution there. We've got x equals 0 for that x on the outside. Now we can go about factorising this quadratic. So obviously if we turn this into a double bracket, our factors of 9, we can have 3 and 3, or 1 and 9. And if we want to make negative 6 in the middle, it's going to be minus 3 and minus 3. So x minus 3, x minus 3. There we go, and we've got that x on the outside. So there is the equation of our graph if we factorise it. And then obviously again that gives us our three solutions. So we get x equals 0 for that one there. We get x equals 3 for this one here. And x equals 3 for this one here. And again, we know there's no y-intercept because we have no number at the end of this equation here. So we know the y-intercept is going to be 0, which we've also proved just via this solution here of x equals 0. So we can go about just drawing it just like we did before now. So draw your axes, it's positively sloping, it goes through 0 and it goes through 3. And it's just going to touch on 3 as well, as we've got those two solutions here of 3. So in actually just drawing that, and not forgetting this isn't the nicest one to be fair, because we've got two solutions at 3, so you just need to watch out obviously the fact that it's sloping up. And it's going to go up through the origin. Oh, let's do that again. Up through the origin, down, just touching at 3, and then sloping back up again. Right, there we go. So no y-intercept, well, the y-intercept of 0, and obviously those two solutions on 3, so just touching on the 3 point there. Okay, so this question says sketch the graph of y equals, and then we have our equation there showing clearly the coordinates of the points where the curve meets the coordinate axes. Now if you look at the equation that we've been given, you can see that if we were to expand that out, our highest power would be a power of 4. So this is going to be a quartic graph. And when we have a quartic graph, there's two different ways that it's going to look. We could have a positive quartic graph, which is going to have this sort of shape with a little wiggle, or we could have a negative quartic graph, which is going to have this sort of shape. And again, those wiggles that we have in the graphs are going to be slightly different depending on our roots. So we know this is going to be a negative one, so it's going to look like my graph on the right. So we know which way it's going to be sloping, we just need to figure out those roots. So to start with, we have the pieces at the beginning. So the x at the beginning just here represents a root where x is equal to 0. So we know one of our roots already. For the second one we have 3 minus x, and again if you're not sure on the root there you can set it equal to 0 and solve it. So if we say that 3 minus x is equal to 0, and if we add x to the other side we get 3 is equal to x, or of course we could write that as x is equal to 3. If we move on to our quadratic there, we're going to want to factorise that to find our roots. And if we factorise this final quadratic, we get in double brackets x plus 2 and another x plus 2. Now that could be written in a slightly different way, of course. We could write that as x plus 2 in brackets squared. Now when we have that going on, that means we have a repeated root, which means our curve at some point is going to bounce off the axes. So if we go about drawing a sketch of this and we draw an axis, we obviously have all our roots. We have x is equal to 0, which we can label on there. We have x is going to be equal to 3, which we can label over here. And we just need to get our root for that x plus 2 in brackets squared. So the root for that is going to be x is equal to negative 2. And of course that's a repeated root, so we don't have to draw that twice, but we're going to want to label negative 2 over here so that we can make sure this curve looks correct. So we know the shape that it's going to be in, and it can help to draw the shape just to the side of the graph, if that helps, just so that you can remember what it's going to look like. So for a negative one, it is going to have this sort of shape, and we're going to need to draw that onto our curve, or onto our axes. So for this particular one here, when we draw this one on, the first thing that you're going to notice when we go up is that straight away we have that repeated root. So as we come up to the negative 2, it's going to bounce off the axes. It's then going to go up through the 0, as that's our next root. And then it's going to go up a certain distance and it's going to come down through the 3. So you can see we have that negative quartic shape. And again, the first thing we had to be aware of was obviously that bounce there for our repeated root, but 0 and 3 were distinct roots, so it does pass through those points. Okay, so this question says sketch the graph of y equals 3 over x with a minus 1 at the end, and we'll have a look at that in a sec. It says showing any points at which the curve crosses the coordinate axes and writing down the equations of the asymptotes of the curve. So let's have a look at this line equation to start with. Now we know from graph transformations that if we change the x value, it'll move it left and right, and if we change the y value, which is what this does at the end here, it moves it up and down. So minus 1 at the end, thinking about a graph transformation, and from GCSE we'll have sometimes seen it like this. We might have seen f of x, there we go, with a minus 1 at the end. And that there is outside the bracket, it affects the y coordinate, and minus 1, it does what we expect, it moves it down by 1. So if we draw a little sketch of this to start with, I'm just going to have a look at, to start with, the graph of y equals 3 over x. So y equals 3 over x, and what does that look like? Okay, and we're going to draw this on pretty much all these questions, and it goes into this area here. Now if I then do this transformation, so I'm going to do this function here, I'm going to take away 1 at the end, which moves it down by 1. we'll have a look at a basic sketch of what that looks like. There we go. So if I move it down by 1, then this part here is going to go down below the axes, and this part here is also going to move down as well. And that's what our graph there is going to look like as a basic sketch. Now thinking about those asymptotes, obviously on the first one here that I've drawn by 3 over x, and let's just label that other one there. So this one here is our y equals 3 over x, but with minus 1 at the end. Originally, as we mentioned on the first bit, our asymptote across this way, which has the equation y equals 0, has now moved down by 1. So it's going to move down 1 here. There we go. And that's going to move down to minus 1. So y is going to equal minus 1 for that asymptote. There we go. Now obviously the graph here has moved downwards, it hasn't moved left or right, so our original asymptote over here, which goes down, which has the equation x equals 0, is not going to change. Okay, so that is going to stay exactly where it is, and we've still got that asymptote there where it never touches the axes. There we go. So x equals 0 is going to stay exactly the same. Now there's one more element that we need to have a look at, because obviously on our first graph it never crosses over the axes, but now we've moved it down, this one on the left does cross the axes. Okay, it crosses over just here at that point. So we need to find out what is that coordinate just there. And there are two ways of doing this, because it either crosses over the x-axis or the y-axis, and at that point there it crosses over the x-axis, and if a graph ever crosses the x-axis, the y-coordinate there is 0. So for that point there, I know that y is equal to 0, and all I need to do is sub that into my equation and solve for what x is going to be. So if I put that in, obviously we're looking at this equation here, y is equal to 3 over x minus 1. So if I put 0 into there, we have 0 equals 3 over x minus 1. And I just need to solve that. So if I add the 1 over to the other side, we get 1 is equal to 3 over x. There we go. So 1 is equal to 3 divided by something. Now logically we know that the answer for that is 3. 3 divided by 3 equals 1. But I also just need to keep going with this and obviously just solve it in a normal way, because some of them aren't going to be quite as obvious to see. So I can multiply the x over to the other side. So I get 1x, or x equals 3. There we go, so I'm actually just multiplying it over. That's quite a nice one because it straight away gave me the solution there as x equals 3. But there we go, that's the point at which it crosses over the x-axis. So I'll just get rid of this and I'll label that on the graph there on my sketch, and I'll put that as 3. There we go. It says here on the same axes, sketch the graphs with equations, and then we have these two equations to draw here. So we've got y equals, we have x brackets x plus 1 brackets x minus 4, and we also have this other graph, y equals 2 over x plus 1. It says to indicate all the points where the curves meet the x-axis, and hence write down the number of real solutions to this equation here. And yeah, as you can see, they've set those two equations equal to each other. Okay, so we have the x with our brackets here, and we have our other graph, 2 over x plus 1 on the right. So we're going to have a look at obviously doing that and drawing these graphs and seeing how we approach them. Now first things first, we need to be aware of the different types of graphs that we could be looking at drawing. Obviously, forgetting about straight line graphs for the moment, just thinking about our curves as both of these are, we can have a quadratic, a cubic and a reciprocal. Okay, and there are other graphs as well, but throughout this video they're the main ones that we're going to be focusing on, with a little bit of straight line graphs thrown in there as well. But at each of these points we're either going to have, and I'm going to draw these to the side, we could have a positive quadratic, which makes a U shape, or a negative quadratic, which makes that N shape. We can have a positive cubic, which makes this sort of shape, or a negative cubic, where we have a negative x cubed. And then as well as that, we can have our reciprocal graphs as well, which depending on how we draw our axes, we can have our positive reciprocal, which has a little bit, well, looks a little bit like that, or we can have our negative reciprocal, which looks just the other way around in those two. Okay, so we're going to be mainly drawing these 6 graphs here, and obviously, as I said, you need to make sure that you're happy and aware of these sketches here. So obviously do check out sketching quadratics, cubics and reciprocals in the videos in the description. So let's have a look at this first one then. Now the first graph there, we have 3 x pieces that are going to be multiplied together. There is the x, there's the x there, and the x there, and they're all positive. So that's going to make a positive cubic graph. Now the solutions are given to us in this particular one here, because it's already been factorised. So when we've got that one there, we've got the first x at the start, which gives us one of the x interceptions, and that's going to be x equals 0. So I'm just going to write this down. We've got x equals 0 as our solution for that one. We have the x plus 1, okay, and that's going to be x equals negative 1. Okay, remember you just flip the signs, or you just set it equal to 0. Remember, if there are any difficult ones, you can just set it equal to 0. So we can say, when does x plus 1 equal 0? And then minus the 1 from both sides, we get the x equals negative 1. Which is why you can just flip the signs, but don't forget you've got that process there if any more difficult ones come along, which they will. And then we've got the last one there, where x minus 4 in the bracket, and that gives us x equals positive 4. So there's our 3 solutions, and we already know the shape of the graph. It's going to be a positive cubic, so it's going to look like that. So if we start to draw our axes, let's just draw it in. And I'm not going to actually draw this graph just yet, but I am going to put these points where I know it's going to cross over. So we have -1 and 4, and remember it is just a sketch, so it doesn't have to be absolutely perfect. It's more about where it crosses over and the shape of the graph that we're getting correct here. So there we go. I know it needs to be around about that big for the moment. Now we have our other graph there. Now that one below is a reciprocal graph. Whenever you're getting a divide by x, that's going to form a reciprocal graph. Now it's a positive x, so it's a positive reciprocal. So we know in terms of just a little basic idea what it's going to look like. It's going to look something like that. But this one here also has a +1 on there. And hopefully you'll remember that with a +1 at the end, that's going to change the y-intercept. Okay, or in other words, obviously we don't have a y-intercept with our reciprocal graphs, but with a normal graph, it changes the y-intercept, it moves it up 1. So in terms of our reciprocal graph here, that is going to move up 1. And if I draw just over the top of my sketch there, it just means it's going to be up a little bit higher. Okay, so it's going to cross through the x-axis in that negative region there. Now in terms of actually drawing this, before I draw the sketch, again I just want to know where it crosses the x-axis, okay, because I don't want to have to redraw my sketch twice. So let's figure out where it crosses the x-axis, and that's easy enough to do because we can just set y equal to 0. Okay, remember that from coordinate geometry. If you ever want to find where a graph crosses the x-axis, just put y equals 0 in. So if we sub that in, let's do that down here, we get 0 equals 2 over x plus 1. And just remember, the reason I'm doing this is because any position on the x-axis, the y-coordinate is 0. So if we sub that in, and now we just need to solve it. Not the nicest one to solve, just because we have a little bit of movement to do. It looks like it should be nice and quick, but we have to minus 1 from both sides. So we get minus 1 is equal to 2 over x. Multiply both sides by x, so we get negative x, or negative 1x equals 2, and then divide by negative 1, and we get x equals negative 2. There we go. So there we are, we know it's going to cross over at x equals negative 2, and I'm going to write that down up there, x equals minus 2. I'm just going to mark that on the graph as well. There we go, minus 2 there. And now we can go about drawing these in, because we know where it's going to cross over all these different points. So if I draw the reciprocal in to start with, so my reciprocal is going to look something like this. And the other one on the right there is also moved up, so something like that. Again, it's not perfect, okay, but you just have to draw these as best you can. Just extend that axis there. And there's our first part of drawing the reciprocal. Now I didn't have to draw that one first. I could have drawn the cubic first, but as I've just finished that one, we'll draw that one in. Now the second one that we need to draw here is the cubic. And like we said, we already know what it looks like. We've drawn a little sketch of it up here. So it's going to go up through that minus 1, back down through the 0, and then up through the 4. So if we go up to the minus 1, back down through the 0, and then up through the 4. And again, I could probably just extend that reciprocal graph a little bit. Again, it is only just a sketch, so you are going to have these little situations where you're drawing them where they don't quite meet, or you haven't quite drawn it big enough, or maybe you've drawn it too small. Okay, so if you do that, obviously just make sure you're always drawing it in a pen with a pencil and ruler, and you can always just rub it out and go again, or just draw a second sketch. Okay, it's all about just a little bit of practice with these and just perfecting your graphs as you draw them. But there we go, there's our sketch. If we actually put this onto a graphing calculator, we'd probably see that it's not perfect. Okay, and these little dips and within that cubic graph could potentially be a lot more stretched out, but as it's only a sketch, we're not going to stress too much about that. And actually we'll have a look at what it looks like in a sec. But before we do that, it says here, hence write down the number of real solutions to the equation. And then what they've done here is they've just set them equal to each other. Now, if you remember from GCSE, if you want to solve two sort of graph equations algebraically, all you have to do, as long as they're both y equals, you just set them equal to each other and find the x coordinate. Okay, solving them simultaneously, and then you sub the x coordinate back in to find the y coordinate. But this question here has said, hence, obviously using our diagram there, write down the number of real solutions to this equation. It doesn't want the solutions exactly, it just wants to write down how many there are. So as we can see on the graph here, we've got one here where they cross over, and we have another one just there. So in total, we have two solutions as the graph crosses over, the graphs cross over at 2 points there. Okay, so we would obviously just say two solutions as the graphs cross over at 2 points. I'm just going to write that in there, two solutions And there we go. Okay, so that's the end of our first question. Obviously there was drawing reciprocal graphs, so there's a little bit of graph transformations there as well, with the +1 moving it up by 1. We actually also had drawing a cubic graph, and we had some solving equations. So as you can see, there's a lot of different topics in here, even though once you've got the hang of drawing these, the topic is actually relatively straightforward, okay, once you've done quite a few of them. But you can see there's quite a lot of topics involved here, so do make sure you check out any of those videos on previous topics, obviously relating to this. But that's our first question. Before we move on, let's just have a look at what this would look like. Okay, so if you use this app, and it's a great little app to use, it's called Desmos. So all we actually need to do to have a look at that graph there is just type in the equations for these two graphs. And it's a really good tool when you're doing topics like this, just for having a look at what these graphs look like. So if we type them in, we can have y equals x, and then what was it? It was brackets x plus 1, close brackets, and then it was x minus 4 in the other bracket, x minus 4, there we go, and that's going to give us just a little overview, or kind of little look at what it actually looks like. If we put our second graph in then, which was y equals, we had 2 over x, so 2, and we'll put divide by x, there we go, come out of the fraction, and then we'll put the +1 there. And that shows it obviously moving up slightly. Now it's really good look, because obviously we can see that our graph wasn't too far off, the reciprocal looked good, and the negative part of the graph on the left there looked good, but obviously this dip was a lot bigger, well, a lot smaller on the sketch that I drew. Okay, but as I said, it is just a sketch, but it's a great little opportunity just to have a look and actually see if your sketch is correct. And as we can see, there's one crossover point just there, and there's another crossover point just there. And as well as that, we can also see where it crosses through the x-axis. We can see the -2 over here that we had. We can see these solutions here, the -1, the 0 and the 4, and we can pretty much check everything that we had on that question. So just a little thing for you to have a look at. It's called Desmos. It's a great little app. You can get it on your phone or on an iPad or on a computer. It doesn't really matter what device you use, and you should be able to access this on anything. So there we go, just a little thing to show you along the way. Let's have a look at our next question. So this is the diagram, shows the part of the curve with the equation y equals f of x, and here it is in the diagram. The maximum point of the curve is 2, 3, as we've already seen. Write down the coordinates of the maximum point with these different equations, and I've got quite a lot here, all the different scenarios we could actually have a look at. So for part A there, okay, it says f of x minus 2. So that's inside the bracket, so it affects the x coordinate, and it does the opposite of what we'd expect, so it doesn't subtract 2, it adds 2. Okay, so it just does the opposite, so the x coordinate being 2 there, we would add 2 to the x coordinate, and that would make it 4, and the y coordinate's not going to change, so that would stay as 3. Okay, so that's the opposite of what we'd expect, and we add 2 to the x coordinate. Look at the next one. Let's try to change to a different colour here. Right, so f of x minus 1. Now that minus 1 is outside of the bracket, so it's outside the bracket, it affects y, and it does exactly what we'd expect. So minus 1, we would expect that to subtract 1 from the y coordinate, which it does. It just changes the y-intercept actually. If you're familiar with your equations of lines and your coordinates, coordinate geometry, you should hopefully know that number at the end is the y-intercept there. So it's taking away 1 from the y-intercept, essentially just moving the graph down one, but we'll have a look at that again a little bit later. But minusing 1 from the y coordinate currently is 3. So if we take 1 away from that, the x coordinate doesn't change, so 2. But the y coordinate's also going to drop down there to 2. It's going to subtract 1 from that. Okay, so that's how we could have different scenarios there with just adding and subtracting numbers, and how that affects the x and y coordinate. Now we're going to have a look at question C, part C there. So y equals f of 2x. So 2 times x. Normally when you're timesing by 2 you'd expect that to double something, but as it's inside the bracket affecting x, it does the opposite. So rather than multiplying by 2, it divides it by 2 or halves it there. So if we look at the x coordinate is currently 2. So half of that, halving it because it's inside the bracket, changing the x coordinate but does the opposite. So half of 2 is 1, and the y coordinate remains unchanged, and that remains as 3. There we go. So that's that one. Let's have a look at the other scenario where it's outside the bracket. So 3 lots of f of x for part D here. Let's have a look at what this does. So it's outside the bracket, it affects y, we're multiplying it by 3. So it does what we'd expect, it makes it 3 times bigger, but it affects the y coordinate this time because it's outside the x bracket. So 3 lots of that y coordinate, the y coordinate's currently 3, so the x coordinate is unchanged and the y coordinate gets multiplied by 3 and becomes 9. Right, there we go. So that is our scenarios where we are multiplying by a number. So in terms of the x there, inside the bracket 2x does the opposite, so divided by 2. But outside the bracket it multiplied the y coordinate by 3. Okay, and on to these negative ones here, which don't really follow the same trend, but partly it does. So we'll have a look at this one here. So when we've got minus x in there, now it doesn't do the opposite of what we'd expect, because the opposite of minus x would just be nothing. Okay, we wouldn't actually change anything at all, it'd just be positive x, it'd be the same equation. Okay, but we follow the rest of the rules for this one. It's just that it goes a little bit out the window when we look at our minuses here. So when we've got a minus in there, all that does is it swaps the symbol of the x coordinate. It's still affecting x, it's inside the bracket, it just doesn't do the opposite this time. Okay, so it just changes the 2 as the x coordinate to minus 2. So the x coordinate's going to change, it becomes minus 2, and the y coordinate remains unchanged, stays as 3. Okay, so this one is a negative in there. That's the only scenario where it doesn't actually do the opposite or anything like that. We just have to worry about, is it next to the x or is it changing the y, and it just flips the sign. So the last one here, we've got y equals minus f of x, and again the minus there is outside the bracket, so it changes the y coordinate, and again it just swaps the sign. So instead of being positive 3 there as the y coordinate, it's going to be negative 3. So we have positive 2 still, and negative 3. Okay, so again, just following all those little rules. Is it next to x or is it next to the y, or outside of the x bracket? And that tells us which coordinate it affects. When it comes to adding, subtracting, multiplying, okay, we can think about the opposite or whether it does what we'd expect. The only scenario where it doesn't is where we've got this little minus symbol in there, and that just changes the positive or negative symbol of the corresponding coordinate, whether it's x or y, whether it's inside the bracket or outside the bracket. Okay, so it says the diagram shows part of a curve with equation y equals f of x. Draw a sketch of the graph with these two equations. So I'm going to do 2 on one graph just to save a bit of time here. So part A says to draw y equals f of x minus 4. Now we know that x minus 4 here is going to plus 4 to all the y, or toward the x coordinates. So add 4 to x. Okay. Now all we've got to do is make sure that we find any whole number coordinates on this graph, and they're the key ones. So I can see quite a few, and I'm going to highlight them here. So we've got one here, we've got one here, and we've got a few down the bottom here that go through actual whole number coordinates. So they are the coordinates that I need to make sure I move perfectly when I'm drawing my little sketch. The rest, we can just do it as accurately as we can. So if we're going to add 4 to the x coordinate, well, let's look at this one here to start with. That coordinate there currently is 0, 4. So when I add 4 to the x coordinate, that is going to become 4, 4, okay, adding 4 to the 0. So 4, 4 is the coordinate here. And you can see there, that's moved it right 4 spaces, and that's what that transformation there actually does. Okay, so when we actually add 4 to the x coordinates, they're all going to move right 4, and therefore it's going to be translated, okay, to the right. Okay, so we're translating it 4 to the right. Now looking at the other one, this one here, if I move that 4, that's going to land on top of that 0, 4 coordinate, so I can't draw over the top of that, that's where that's going to move. The one down the bottom here, this minus 2, that if we move that right 4, that's going to go to here, and then moving the others right 4 is going to place them there and there. There we go. And that is how they would move. Now if I just get rid of some of these bits here, because we're going to do another one in a sec. Let's get rid of all of them, and let's just sketch that in. And you've got to just do this nice and neat, okay, as best you can, drawing a nice smooth curve, making it look as best as you can, like the one on the graph there. There we go. So not perfect with my lines there, but just moving it right 4 and showing that it goes through those whole number coordinates. And let's have a look at part B here. We've got y equals f of minus x. Now minus x, we know, changes the symbol on the x coordinates. So again, if we pick a coordinate, and let's pick this one to start with. Okay, so this one here, let's label this over here. That coordinate there is minus 2, 0. Okay, so if we swap the symbol on the x coordinate there, that's going to become positive 2, 0. Okay, so positive 2, 0. Again, let's get rid of this first graph. Positive 2, 0 is here. There we go. So let's have a look at another one. Let's pick this coordinate here. There we go. So that coordinate there is minus 1, 0. And if we change the symbol in front of the x coordinate, that becomes positive 1, 0. So positive 1, 0 is there. And let's have a look at one more down here on the bottom. We might be able to figure out where the rest are going to go afterwards. This one here is minus 3, 0. And again, swapping the x coordinate there, that becomes positive 3, 0, which is just here. So hopefully you can see it. Actually, this curve is going to end up in exactly the same place as the last one. But what's actually happening here, let's have a look, let's just get rid of all this so we can see it a bit better, is something slightly different to the last one, because that last one was a transformation. It was actually moving right 4, whereas if you have a look at, and I'll try and do them in a different colour here, this coordinate here, the purple one, moved to this coordinate here. So actually it's not being moved in the same way, because as well this coordinate here is moved to this coordinate here. What this is actually doing is reflecting the shape in the y-axis. Okay, and you might actually be able to see that this coordinate here as well would move to, just make sure I do this carefully now, I'm not writing down the coordinates, it would move to there. And the coordinate which is here on the axes is not going to move anywhere, it's going to stay where it is. So actually what's happened is the curve has been reflected, but all you've got to do is reflect those, or change the symbol in front of those x coordinates, and again just sketching it in nice and neat. So it's quite unique there because, oh, there we go, not very good there. Make sure you do go through the coordinate points. But although there were two different